Hello everyone, I'm going to discuss how to read a connection diagram on a specified connection reference to find the reference block showing all the electrical devices, components, mechanical symbols and graphical symbols for electrical engineering diagram. I am going also show you how to trace if the electrical input or output is coming in or coming from. Identify graphical electrical symbols and components. Figure out and realize the appearance and physical and architectural structure, access, contacts, configuration, and wiring arrangement devices or components within your electrical systems. Interpret how the electrical and electronic components, mechanical switches and contacts, how it operates. Among those integrated components and devices will actuate their contact from normally open to normally closed, to normally open. Visible signals through electrical indications and audible signals through an alarm. Of the input signals and parameters such as pressure parameter signals, such as analog signals, included the pressure, the temperature, the electrical signals for current, voltage, and frequencies. Opening and closing of contacts, on-off operation of switches, RPM pickups, proximity switches, limit switches, and pressure switches. How the electrical system will operate and working as it is designed on the specified electrical connection diagram to specified conditions and that your electrical system is purely operational. Marks, contacts, and a connection diagram. Confirm, verify and check if the electrical connection diagram is specified on your plan or sheets satisfactory or in accordance with design. Here to show you how to do those things. Shown diagram of the emergency generator and control circuits. Connection to the auto control circuits. Connection diagram of the emergency generator control panel and connection diagram in the main switchboard. On how the automatic starting of the generators and automatic closure of the emergency generator to supply power to your emergency switchboard during a power blackout. Okay guys, now I have here the 4 sheets of the electrical connection diagrams on how the emergency generator is automatically started and its automatic BUSTIE switch with its circuit breaker will automatically close to supply a voltage from emergency generator power to give supply on the emergency switchboard bus bar. Diagram is about emergency generator and BUSTIE switch control circuits. In this diagram is about connection diagram of auto control circuits, and this diagram is about connection diagram of external circuit on the emergency generator control panel, and this connection diagram is about external connection diagram circuit from the main switchboard. Each connection diagram have their own drawing number and sheet identification. This drawing number and sheet identification are the best tools for you along the way when to find, interpret, identify, interpret, determination, analyzing, confirmation, verifying, and checks, and locate those wire markings and contact markings to realize how the electrical system is functioning and being operated. Okay, to begin with, these three bus bar line is the bus bar line going to the emergency switchboard bus bar. This emergency switchboard bus bar taking his power from short connection from the main switchboard, from the emergency generators. As you may take a look, this emergency switchboard bus bar taking their power on a three section, from the short connection, from the main switchboard, and from the emergency generator. What we are is the power board going to the ESP bus bar and power from emergency generator going to the emergency switchboard bus bar. The main switchboard power and the emergency generator power is being supplied on the emergency switchboard individually by means of the automatic BUSTIE switch contactor. This automatic BUSTIE switch contactor is interlocked to each other, meaning when the contactor of the main switchboard BUSTIE switch is energized, the contactor BUSTIE switch of the emergency generator will be de-energized. This M is the main switchboard magnetic contactor automatic BUSTIE switch will close when the coil MCC A1 and A2 coil is energized. Once this is energized, the emergency generator automatic BUSTIE switch contactor will be open. Possible to energize this coil ECC for emergency generator BUSTIE switch since it is interlocked with the contactor M. As you can see these points, this is an auxiliary contacts of the contactor M. With the contactor M is closed because the MCC is energized. This normally close auxiliary contacts of the main switchboard automatic BUSTIE switch will be open. This will be open. This 21 and 22 auxiliary contact of the contactor M for main switchboard BUSTIE switch is interlocked with contactor E of the emergency generators, so that you cannot close the emergency generator contactor automatic BUSTIE switch if the main switchboard automatic BUSTIE switch is closed or energized. Okay guys, now we are going to talk and discuss during a power blackout the emergency generator and how the circuit breaker of the emergency generator and BUSTIE switch is being closed. Give power on the emergency switchboard as well. What I have here is a one-line terminal position, or known as one-line diagram of the emergency switchboard panel. This emergency switchboard, as you can see here, there is TB1, TB3, TB2, and TB4. This TB1 is a power from emergency generator. As you can see, generator going directly to the automatic BUSTIE switch. This is automatic BUSTIE switch. During a power blackout, the main switchboard power is no longer available. Going to the emergency switchboard busbar. Since the power from the main switchboard is not available, these two fuses F96 8 ampere has also no voltage coming from the main switchboard. Since this line going to the fuses has no voltage going here for the relay B1B, EPC, MCC, B1A, and this fuse F96 also have no voltage coming from the main switchboard going on this line. This MCC coil relay of the magnetic contactor M will be de-energized. Once it is de-energized, this contactor from the main switchboard automatic BUSTIE switch contactor will be open. De-energizing the MCC contactor coil and also the contactor B1B, B1, as you may take a look on it, this B1A has a reference connection diagram stated A, V, J1, J1, B1. These connection references is a waypoint for you to find the details on the B1A. Once the relay B1A is de-energized, it will give signals to start automatically the emergency generators. connection diagram sheets with J1. I have here another connection diagram sheets. This connection diagram sheets is stated drawing number JSB8101J1. This drawing number with equivalent connection diagram sheets J1 are the connection diagram sheets specified on the drawing number JSB808101 on the relay contactor D1A AV D1 J1 D1. Once the relay coil of the D1A is de-energized, this B1A K91 contacts, normally open contacts, will close. Once this B1A contact is closed, it will energize the relay 27, 1 and 2. This relay 27, 1 and 2 has a contact from this terminal 27-1. When this is open, you will not able to energize the WT on delay timer and the starting ST or starting timer with 35 seconds. The signal from here going on the terminal number 1. This R1 is another reference number specifying that the AL12 connection and AL10 connection is on at automatic position, means this contact is closed. Since this contact closed, it will take the signal or electrical signal on this 84N going on the going to the TB3 NO means positive, negative, and POV having a fuse of 101 with 20 amperes. This TB3 positive and negative supply going to the fuse 101 20 ampere are come from the emergency generator control panel. As you can see, 8101 R1, there is a terminal block TB4 and TB3. This is where the 24 volts supply are come. This TB3 going to the fuse 102 10 ampere, and here there is a connection going to the power panel J1. This is another connection references specifying that this line is going on the drawing connection sheets with ending letter and number J1. And from here, this is a drawing number JSB 8101 with sheets number J1. Where to find the supply from TB3 going negative going on this terminal block going on these poles passing here, going here, and then from here, since this is connected during automatic going this, and then as you may take note, once this is energized, this normally open. As you may verify, these symbols means normally closed, but on actual, when I take a look on it, this 27-1 is normally open. Since this is normally open, while this 27-1 is energized, this normally open contact will close. Once the contact is closed, the electrical signal will energize simultaneously the ST timers and WT. ST is energized, it will give a pulse signal. It will give a pulse energize the relay STA by means of each of delay ST auxiliary contacts. Within 2 seconds of the STA will remain closed. While it is closed within 2 seconds, terminal 83 will complete the circuit on terminal 82 to start the emergency generators. Since the electronic relay STA is energized, this contact, it will give signal to start the emergency generator. The signal from the C1 common emergency generator control panel. See here, I have another sheet specifying drawing number JSP8101R1. On this connection diagram, it will show the terminal C1 and C2 of STA relays and giving a signal within 2 seconds, engine start. Within 2 seconds, the generator with the WT on delay timer will count about 35 seconds. And from here, JSP8101-P1, you will find the on delay timer contacts WT terminal 44 and 46. While this on delay contacts is counting about 35 seconds, the generator, emergency generator is running, and the circuit breaker of the emergency generator is held closed. The transformer will give signal on the watt-hour meter instrument. This watt-hour meter instrument produce an equivalent voltage on terminal RT. This terminal voltage RT will be delivered and supplied on the voltage detector system on the emergency switchboard, emergency electronic panel. Then after 5 seconds, when the voltage of the emergency generator reaches about 95%, 450 volts, around 400, these voltage detectors will energize. This voltage detector spring contacts will make a contact to energize the relay RY1. This relay RY1 is the responsible to switch off the electric heater inside of the generator by having this contact and making a complete path of signal from 3. This contact number 3 will close on the terminal 1. Then the signal will crossing seconds, this will close. When it closes, the 24 volts DC signal will going here and then going on the emergency generator terminal contacts. And from here, this ET1 relay is the energized, and this normally closed contact will allow the signal to supply the ETT relay, the MT1 relay, and then once the ETT relay is energized, it will count 1 second delay to make the contact. To make the contact, the relay EC1. Once the relay EC1 is energized, a green light indicator light will be illuminated on. Also, energizing the EC1 relay will make the contact between here C1 common to the EC. Once this EC1 contact is closed, it will pass the signal going on the terminal 21 and 22 of the magnetic contactor N. As you can see, the magnetic contactor M, this one M, is energized because this MCC coil of the magnetic contactor M, automatic bustling switch, is energized. This interlocking auxiliary contact is closed, allowing to pass the voltage going to the ECC A1A2 coil of the emergency generator automatic bustling switch contactor E. But take note, the magnetic contactor ECC or emergency coil contactor of the generator is going from here and then going on this bus bar line of the emergency generator. This means the control voltage of the magnetic contactor of the emergency generator bustling switch is 450 volts. Once this coil A1A2 of the emergency generator contactor is energized, this will close within 35 seconds. In a generator is held closed, the auxiliary contact AX C1 and auxiliary contacts of AX A1 is closed, going to the 52E of the J1. J1 is a connection diagram sheet going on the drawing number JSB81 JSB on this connection. 52E from B1, AX1, AXA1 and AX. Because this contact is closed, the signal will go to energize the 52 terminal 1 and switch terminal 2. This terminal 1, pipe 2-1 and pipe 2-2 is a switches of the relay pipe 2, 1 and 2 to indicate that the circuit breaker is closed or open. And since the relay 52.1, the contact 521, this terminal number 6 will go this way. The terminal 6 and 7 is now having contact to each other. Then allow the signal voltage on the indicator light that the circuit breaker is closed. A connection wiring diagram, and now you know where to find connection drawing reference number, tracing out where is the component or electrical devices is being connected, interpret how the electrical component and devices, how it functions, determines parameters and conditions on how the electrical system is being operated to do a process, analyzing and visualize behavior and actual physical and architectural structure or wiring arrangement of your components and devices on the electrical system. And now, you will be able to confirm and verify and check that your electrical system is working properly in accordance with the electrical connection diagram as shown on the electrical connection. Electrical connection is being designed or illustrated on your electrical diagram. So guys, for being electricians or electrical engineers on board ship is not an easy task. It's not an easy task. This is not simple, and this task requires understanding, patience, and discipline. Then practice perfect. Do your best, and God will. Thank you for watching. Abbreviation and special symbol list. This special symbol list can be seen on electrical wiring diagrams for your electrical systems on ships. Electrical wiring diagrams on ships normally have special symbol lists and abbreviation. You can find there a lot of letters and symbols. The ETR, the ETO must need to familiarize themselves on those special symbol abbreviation lists for them to learn and easily comprehend with electrical wiring diagram. Okay, if you can see there is a letter A, this A, you can find some abbreviation, and those abbreviation example A means ammeter, AC means alternating current, ACB means air circuit breaker, AS means ammeter switch, AT means auto transformer, auto means automatic, AUX means auxiliary, BCC means balance control console, BCS means breaker control switch, PELL means bell, PRCC means bridge control console, BSP means battery switchboard, BTS means bus time switch, BZ means buzzer, CAP means capacity, CIRC means circuit, CNP means caution relay, COS means change over switch, COSA means ECL means JE control position switch. DC means direct current. DM means dimmer. CMP means complete. DS means disconnection switch. This abbreviation and simple list means earth monitor. Emerge means emergency. ESP means emergency switchboard. EX exciter. EXH exhaust. ER means engine room. ECC means engine control console. ECS means engine control switch. EGCP means emergency generator, engine control panel. FC means flowchar. FLS means fluorescent lamp switch. SLX means fluorescent lamp. FM means frequency meter. ESP group starter panel. GL green lamp. HM running hour meter. HS handle switch. IN incandescent lamp. INS incandescent lamp switch. INN interlock switch. INST means instantaneous. KS means night switch. KW means 1 meter. L for lamp. LS for limit switch. LSS for load switch. Load shift switch. LTP test terminal. Manu means manual. Max maximum. MC means magnetic contactor. MCCB means voltage case circuit breaker. MCC means main control console. Min means minute. Mini means minimum. MSP means main switchboard. MP means magnetic valve. MS means machine side. NC means normally closed. NOR means normal. NOR means normal. LP means nameplate. OCRY means over current relay. OL means orange lamp. PLC means program sequence controller. PBS means push button switch. PM plug in mount. PNL means panel. Pref means preferential grip. PS means pressure switch. PF means power factor meter. PL means illuminated push button. R for resistor. RAT for rating. RC for remote. RO for RCS for remote control switch. REC means rectifier. Rev for reverse. RM means room. RPRY means reverse power relay. RL means red lamp. SCR means silicon control switch or rectifier. SEC means second. SEP means separate. SEQ means sequential. SH means space heater. SHA means space heater switch. SHT means shunt brake. ISG means signal. ST means starter. STB means starboard. STBY means standby. SUP means fly. SW means switch. SWBD means switchboard. SY means single stroke. SYL means single lamp. SYS means single scope switch. SL means skyfall lamp. We have a lot of abbreviation and symbol lists. TP means terminal mode. TT time delay. Temperature. TH thermostat. TR transparent lamp. EM thermometer. TR transformer. TS thermoswitch. UVP is the under voltage protection. UVR means under voltage release. UVT means under voltage strip. P for voltmeter valve. PEG for vegetable. PR for volt regulator. PS for voltmeter switch. CT means volt transformer. WHM means for watt hour meter. WH wheelhouse. WL white lamp. And among of these, we have also some special symbol lists. As you will see, we have the electrician, ETO or ETR must need to know so that you can easily compare contact symbols and switch circuit breaker symbols. These symbols have equivalent descriptions. Means jump general symbol, conductor general, junction of conductor, crossing conductor connected, crossing conductor not connected, terminal, connection references, device fitted in the other panel, group conductors, earth, resistance or resistor, variable resistance, resistance or resistor with tap, space heater, condenser or capacitor, voltage transformer, transformer general, auto transformer, indicator lamp with button switch, fluorescent lamp, timer, current transformer, electromagnetic coil, rectifier of diodes, AC source general, generators, terminal board, motor, running hour meter, ammeter, voltmeter, element of overcurrent relay, UV 300 voltage coil, shunt coil, switch general, bell, buzzer, magnetic brake, equipment of other unit, fitted outside. Among of the mechanical contact symbols are as follows. This means contact or manual contact, manual operate, automatic reset, mechanical operate, control switch and fail, delay or auxiliary switch, time delay operating, time delay reset contact, flicker, manual reset, magnetic contactor, manual operate auto reset lapping contact, controller cam type on or off. I have also here symbol for switch and circuit breaker. Here I have the single line diagram or symbol and schematic. This schematic diagram means switch general, air circuit breaker fixed type, air circuit breaker with drawable type. This means a molded case circuit breaker. This is a molded case circuit breaker or light switch. Here I have a flowchart symbol this. This symbol aside from having an ideas on the graphical symbols of electrical clearing, connection diagrams, mechanical symbols, and circuit breaker connection symbols, you must need also know with the flowchart process for you to do and understand how the electrical system is working. Process and operation box. If you see this box, this means a cost figure. This cost figure means the result of process that you do. This is a predefined condition. This condition specifies how you do a process by automatic mode, by manual mode, by remote operated, or by wireless mode, or steps on automatic or on manual running of a certain system. This means the end condition. Final condition means the end process or the product or the totality result a process. This is the judgment, having yes or no. This is defined as a fairly safe, or this is programmed has a, this judgment is yes, you will proceed to next process. If no, you will come back on the previous process to correct some abnormalities or non-acceptable conditions. This means manual operation. Manual operations means you need to perform by hand. These symbols means an operation. An operation means the integral part. An operation requires or more than 2 input process. If your input 1 is 0 and your input 2 is 1, the result is 0. If your input 1 is 1 and your input number 2 is 1, the result is 1. This is the OR process. This requires a summation of process. Summation means you are going to add a process. If your input 1 is 0 and your input 2 is 1, the result is 1. If your input 1 is 1 and your input 2 is 1, the result is 1. This circles means indicator lamp. Either the lamp is on, either the light is flickered, either the lamp is off or gone out. This symbol means alarm. This is the location. And this EGCP is a designated abbreviation for your electrical connection diagram. Here I have a process. Here I have a flowchart. This final condition is stated that the emergency switchboard bus bar is supplied power. How the final condition is being accomplished. To put the title, our title is Emergency Automatic Start of the Generator due to blackout and Emergency Generator Air Circuit Breaker Closure on the dead bus of the emergency switchboard bus bar. From here you can see the display and how this is how it is started. And on the upper part there is also a final condition. The final condition we wanted to do is to supply the power on the emergency switchboard coming from the emergency generator caused by power blackout on the emergency generator. Here is the preparation. You must need to push the selector switch mode into automatic. This process flow will goes this way. Once the power blackout is happened, within 2 seconds on the emergency control panel detected that there is no voltage with the main switchboard, the automatic start will give signal to start the emergency generator. From here there is a process judgment. On the judgment, the RPM pickup sends the RPM of the emergency generator having 1,800 RPM. If yes, it will go on the next process. If no, it will return and gives an alarm. Emergency generator abnormal. Provided that we have the 1,800 RPM speed and on the emergency generator control panel, the 95% of the 450 volts around 423 volts is being measured or generated and the bus low voltage. In the emergency control panel, there is a timer detection there. On the emergency control panel, it will count about 2 seconds. Within 2 seconds, if there is no voltage coming from the main switchboard, it will automatically start the emergency generator. Once the emergency generator is being started and the speed measured about 1,800 RPM, having volts about 95% to 450, it will count about 5 seconds. Then after 35 seconds, the emergency generator power will be supplied on the emergency switchboard. Then you need to Put the changeover switch on the emergency generator side. Put the BUSTIE switch on emergency generator side. Then you will now have the power from emergency generator when the BUSTIE switch is connected. From here, you are able now to have power from the emergency